So we're moving on to 7.2, which is multiplying polynomials. We've already used the distributive property when we had one term times two terms in the parentheses, but now we're going to be looking at what happens if I have a two terms times two terms. In other words, a binomial times a binomial. So FOIL is a way to remember that we are going to multiply our first terms, our outer terms, our inner terms, and then our last terms. So FOIL is the first letter of each of those. All right, so it says use the distributive property. Distributive property is another word for FOIL. That's the shortcut way to remember it. And all it's saying is that the number in your first parenthesis has to be multiplied by both of them. And actually, this one has to be multiplied by both of them. So if you have a binomial times a binomial, we're actually doing four things of multiplication. So I'm going to start by doing x times x, which is x squared. And then I'll do x times my negative 1, which is a negative 1x. And then I'll do negative 2 times x, which is negative 2x. And then I'll do negative 2 times negative 1, which is a positive 2. So notice when I did this, I multiplied my first two together, then I multiplied my outer two together, then I multiplied my inner two together, and then I multiplied my last two together. So that's your FOIL. So it's reminding you a binomial times a binomial has four things that are being multiplied. And then I've got some like terms that I can combine here. So I have an x squared minus 3x and then plus 2. And that is using the distributive property, or FOIL, for a binomial times a binomial. Okay, so try the next one. So I'm going to show that there's four things I'm multiplying. B times b is b squared. B times 2 is 2b. Negative 3 times b is negative 3b. And negative 3 times 2 is a negative 6. From there then, looking to combine those like terms, I have b squared minus 1b, or minus b, either one, and then minus 6. All right, try these next two and see if you can get them, and then check back in and see how you did. Okay, so I'm going to do a times 2a, which is actually 2a squared. Be careful on that multiplication. And then a times 5, which is 5a. And then I have a negative 1 times 2a, which is a negative 2a, and negative 1 times 5, which is a negative 5. Again, I've got some like terms I can combine. So I keep my 2a squared, and then I have a 5a minus 2a, which would be a 3a, and then I still have minus my 5. Notice I'm putting my answers in standard form with the highest degree term down to the lowest degree term. That's how you should be writing yours as well. Okay, the next one. So 3n times n would be 3n squared, because an n times an n is an n squared, and technically you have a 3 times a 1 out in front, which is your 3. And 3n times 1, which is 3n. Then I have a negative 4 times n, which is a negative 4n, and a negative 4 times a 1, which is a negative 4. When I combine my like terms, I get 3n squared minus 1n, or minus n, and then minus 4. So some things to keep in mind. If I have 3n plus n, that is 4n. But if I have 3n times n, that is 3n squared. So just kind of a reminder on how we deal with each of those either addition or multiplication problems. Okay, so the next section is the exact same thing, but it's just a different way, a visual way to show that there's four things that you're multiplying. So what I'm going to do is I'm going to take this first term and I'm going to write one of them here and the second one in this box. Then I'm going to take this term and I'm going to write one of them here and the second one here in this box. Then I'm going to do my multiplication. So think about your area model. Area says that I'm going to take this side times this side. So x times x is x squared. And do the same thing for this one. This one times this side, x times negative 3 is negative 3x. Then I'm going to multiply this side times this side, so that's a negative 2 times x, which is a negative 2x. And then I'll multiply this side times this side, negative 2 times negative 3 is a positive 6. And then I've got like terms that I combine. So my x squared will stay by itself, but then I have a negative 2x and a negative 3x, which is a positive, it's a negative 5x. I started to multiply. Let me get rid of that. There we go. Okay, so that would be a negative 5x because I'm adding them at this point, and then plus 6. You're going to get the exact same thing whether you use FOIL, the distributive property, or whether you use the area model. So when it says to find the product, we're just finding the area of each of those, but it's the exact same thing. You're doing that multiplication. So try the next two and see how you like this method. Okay, so I'm going to put the y and the plus 1 here, the y and the minus 6 here. Y times y is y squared. Y times 1 is 1y. Negative 6 times y is negative 6y, and negative 6 times 1 is negative 6. When I combine my like terms, I have y squared. I'll have a minus 5y and then minus 6. I've had some people show me that you can just draw a tic-tac board for this as well, and then nothing goes in this spot here. So let me show you how that works. So if you just draw a tic-tac board, cross out that section there, you'd put the Q here and the plus 3 here, the Q here and the 7 there. And it does the exact same thing. So it's just a quick way to draw that box. So Q times Q is Q squared. Q times 3 is 3Q. Q times 7 is 7Q. And 7 times 3 is 21. So then combine my like terms, I get Q squared plus 10Q and then plus 21. Okay, so you've tried both the distributive property, which is FOIL, and the area model. So now you get to choose which method you like best. So down here, it says use the FOIL method. From this point forward, I don't care which method you use. If you like using FOIL, so first, outer, inner, last, the distributive property, or if you like using the area model, it's your choice. I wanted you to see both of them and try both of them so you could see which one you like the best. But now you get to choose which one you want. So I'll actually do number 8 using FOIL, and then I'll do number 9 using the area method just to show you can choose whichever one you want. But even if you use a different method than me, when you check your answers, you should still get the exact same things. Okay, so x times x is x squared. X times negative 3 is a negative 3x. 2 times x is a 2x. And 2 times negative 3 is a negative 6. When I combine my like terms, I get x squared minus, minus 1x and then minus 6. And then I'll do the area model for this one. And again, remember, nothing goes in that spot there. So I have a 2m and a minus 1 and an m and a positive 2. This gives me 2m squared minus m, and then I have a 4m and then minus 2. When I combine my like terms, I get 2m squared plus 3m minus 2. When you're combining, remember, you're adding those like terms there. Okay, so what happens if we have a binomial times a trinomial? Well, it's the same thing. So we'll do the first one using FOIL, and we'll do the second one using the area model. All right, so this first term has to be multiplied by all 3 things. The second term has to be multiplied by all 3 things. Other than that, it's the same thing. So I'll do my x times my x squared, which is x to the 3rd power. Be careful on that one. Then x times x, which is an x squared. And x times a negative 1, which is a negative 1x. Then I do negative 2 times x squared, which is a negative 2x squared. Negative 2 times x, which is a negative 2x. And a negative 2 times a negative 1, which is a positive 2. Notice how I line them up. I put my second things of multiplication down below, but notice I didn't line them up so that the first terms were here, second ones in here. I lined them up so my like terms were combined with each other. So it'll be easy to just add these 2 columns. This one I know doesn't have a like term, and that one I know doesn't have a like term. So just a little tip. So I have x to the 3rd power. X squared minus 2x squared is a negative 1x squared. Negative 1x minus 2x is a negative 3x, and then I have my plus 2. Again, notice I put it into a standard form, so it's descending in my exponents. And I combined all my like terms, so that's my final answer. So notice when I did a binomial times a trinomial, there's actually 6 things of multiplication I had before I combined my like terms. So when you're doing these, do a check. Make sure, did you multiply enough things together? So check that I had 1, 2, 3, 4, 5, 6 things multiplied. So you should always have 6 things multiplied before you combine your like terms. Up here, you should have 4 things you've multiplied before you combine your like terms. Okay, so for number 11, I'm still setting up the same thing, but this time I have an additional row. So nothing goes in this spot here. I will have the d plus 3 on this side. I'll have the d squared minus 4d and then plus 1. It makes absolutely no difference if you had these 2 here and the 3 over here, or if you'd put the 3 on here and put 2 over here. You would have just drawn another line here. It does not matter which one goes on which side. Okay, so d squared times d is d to the 3rd power. Negative 4d times d is negative 4d squared. And 1 times d is just d. 3 times d squared is 3d squared. 3 times negative 4d is negative 12d, and 3 times 1 is 3. So now I'll combine my like terms. I have d to the third power. These are like terms, so negative 4d and a positive 3d is a negative 1d squared. Negative 12d and a positive d is a negative 11d, and then I have my plus 3. So the area method makes it a little bit easier for you to remember that you have 6 things to multiply, or that you have 4 things to multiply. It's harder to miss one because you actually have a blank spot then. But it doesn't make any difference to me from this point on which one you choose. So you can choose whichever one you want to use.